Hi everyone, I'm Marek from ableneo and I would like to welcome you to first part of Elastic webinar series in which we will go through Elastic ecosystem to learn basics of each part of it, and later we will also dig a little deeper to understand how everything works under the hood. Let's begin.
So, what is this elastic ecosystem? There might not be the exact definition, but it is the suite of open source applications curated by a company called Elastic and used for data gathering, processing, storage and indexing, and visualization and analysis. Formally and informally, it is known as Elastic Stack, and also the Elastic itself call it Elastic Stack. To split it into the parts, we have Elasticsearch in the very center. It's the part which persistently stores data, so we can later search over them. It's built on well-known and very well-tuned Apache Lucene indexer with some added sparkles, and actually there is a lot of added features like clustering, so we can easily scale horizontally, REST interface, and JSON format of documents, so it's simple to communicate with it. We have high availability of index data and a lot more. As we have the clustering ability, we might have more Elasticsearch instances, and most of the time we actually do have. We will talk about how does the clustering, data storage, and other interesting features works in detail in next part of this series. Okay, now a short history class. It's year 2004. Shay Bannon's wife had so many recipes, she needed something to be able to search in them. As you can imagine, it's pretty hard task to do that with just a paper notebook. So Shay, as the guy on the screen, come with the idea to create a software which would solve her problem. And after some time, the Elasticsearch was born. Well, it was called Compass back then. He later open sourced it, community started to grow, and now is the most popular indexing software. Now back to the present, we will add Kibana as component used to present the data stored in Elasticsearch cluster. Not only it allows us to see index documents, we can visualize various metrics, see how something in our data changed over time, and even do simple machine learning jobs to constantly analyze anomalies in our data. Apart from that, there are useful tools to manage whole cluster, so for most common cases, you don't need to check the documentation to find how to do it using commands. And if you are missing something, it is not that hard to create custom plugins, it is just JavaScript. So long story short, Kibana is pretty advanced user interface for Elasticsearch. Alright, we can store data, we can display them, but how to get them into our cluster? Well, ladies and gentlemen, please welcome Logstash. It's the component which ingests, parses, and then outputs data into Elasticsearch. To be absolutely correct, the Elasticsearch is not the only output option, but we will take a look at that later. So Logstash runs somewhere, writes the input file, or listens on some port, or checks some database, and in case of incoming or new data, it parses them according to our predefined set of parsing rules. The objective is to parse incoming text data into structured form, so we can later do, for example, visualizations in Kibana over that. To help us with parsing, there is a lot of prepacked plugins like JSON parse filter, grok parse filter, which is a sort of regular expression thing, and eventually we can enrich data, for example, using GeoIP. After the parsing, we should output data somewhere, for example, Elasticsearch, and well, that's it. Input, parse, output, and repeat all over again. These three components, Elasticsearch, Logstash, and Kibana, create so-called ELK stack. Now, everyone likes bees, is it right? Of course it is. So we had bee, and this time I mean that bees that does not produce honey. These bees produce data, and also they ship it around. Okay, now seriously, B represents component called beads. which is a set of small and lightweight data shippers for various type of data. To clarify what I mean, let's take for example FileBeat. It is a program running on the host machine, checking for new lines added to specified file. If there is a new line, or actually it might be multiple lines, it transfers it, for example, into Logstash, which surprisingly has the Beats input plugin. Another very popular beat is metric beat that checks a whole bunch of system metrics and send them to, well, anywhere, Elasticsearch or Logstash, where do you want. The awesomeness of beats is that they are really lightweight, so it is absolutely no problem to have them attached to every running container in cloud environment like Kubernetes. So with added B, our stack animal became a little unreal. We now have so-called elk B. It's the mutation of elk and B, as you can see on the screen. And these are the main components of Elasticstack. And maybe you have been thinking about how you can use that in your project. And that's perfect. And if you didn't, well, these are some use cases for your inspiration. Number one, full text search engine. Well, that was the original idea behind Elasticsearch, and it still is. There are various text analyzers already prepared for you. There are numerous possibilities how to score and order search results. You can use prepared functionalities for search as you write feature. There is fuzzy search, so typos in search queries will still find desired results, and much, much more. In that case, we mostly use only the Elasticsearch, but of course it depends on your architecture if there is need for other parts of stack. Number two, log centralization platform, which is more and more important with emerge of containerization and virtual environments. So operators doesn't have to do shell access and tail log files, which might be very inconvenient task if you have a lot of replicas of some microservice. So combination of beats to ship logs, Logstash to parse them, Elasticsearch to store them, and Kibana to display them is absolute fit for that. Number three is quite similar to number two, usage of Elk Stack as whole monitoring platform to monitor specific metrics of application and or system. This one is used mainly by operations or DevOps teams to be able to quickly recognize their problems, failures, and to be able to quickly analyze and understand why there are such problems. Well, most of the time we use the same components as in the number two. We just add some system monitoring tool, for example, metric beat. Number four, business analytics platform. The ability of Kibana to visualize complex data is perfect for getting to know what is going on from business point of view, from simple visualization of sold products over time to ability to forecast future with machine learning. Just a side note, to be able to use machine learning, you have to buy license from Elastic. It is currently part of paid stack feature. And number five, live updated infographics. With quite a new feature in Kibana called Canvas, it is now no longer a problem to design awesomely looking infographics backed by data from Elasticsearch. This is, for example, a live updated dashboard used by operations of London Stansted Airport. It looks amazing.
And that's all of interesting stuff for today. We'll continue with detailed overview of first Elk Stack component, Elasticsearch, and we will try to unhide secrets of data indexing and searching. See you soon, bye bye.